Welcome, future Lunar Site developers. Let's jump right into this explainer because today we are tackling the ultimate frontier of real estate development, preparing turnkey, move-in ready properties on the moon. You see, before humanity can truly establish a thriving permanent presence up there, somebody has to lay the groundwork. And spoiler alert, it's not going to be an astronaut with a shovel. We're going to explore the absolutely fascinating engineering logistics of establishing a lunar base before a single human even arrives on site.
So here's the multi-billion-dollar question. How do we actually build an entire lunar settlement without risking fragile human lives? I mean, the moon is an incredibly harsh, unforgiving place. We're talking cosmic radiation, unpredictable solar flares, wild temperature swings, and a constant rain of tiny micrometeorites. If we want to construct massive habitats, spaceports, and, well, all the necessary infrastructure, how do we pull that off without putting human crews in constant danger? The answer means fundamentally rethinking our entire approach to space construction.
Section 1. Avoiding the Outpost Trap. Now, the Outpost Trap is unfortunately exactly what it sounds like. It costs an absolute fortune to keep a human being alive on the moon. If we send our highly trained scientists all the way up there, only to have them spend their days restricted in bulky spacesuits doing routine construction labor, like digging trenches or moving dirt, we're essentially wasting incredibly expensive, incredibly fragile human hours. If we just rely on humans for the grunt work, our base is basically never going to expand beyond a tiny limited outpost. Logically, the heavy construction has to be finished long before they even land. And this brilliantly illustrates the massive contrast. Think about a human crew. They're fragile, they're super expensive to support, and they're heavily limited by their own stamina. Now, compare that to Telepresence robonauts. These are our tireless helpers. They don't need oxygen, they certainly don't need food, and they can operate 24/7 through shift rotations back here on Earth. They just keep going, completely ignoring the blazing heat of lunar noon or the freezing cold of the night span. They are vastly more cost-effective for doing all the heavy lifting. Section 2. The Lunar Site Developer. But if you want to be a successful lunar site developer, you really have to master one absolutely critical number, 2.5 seconds. That is the round-trip communication time delay between Earth and the moon, because, light can only travel so fast. When you send a command from your console on Earth, it takes just over a second to reach the lunar surface, and then just over a second for the video feed to bounce back and show you what happened. It sounds super quick, but mastering that slight, tricky lag is literally the key to operating heavy machinery on another world. Luckily, technology is bridging that gap at lightning speed. We are entering an era developers are calling Teleoperation 2.0. Thanks to advanced telepresence, your eyes will see exactly what your robotic avatar is looking at up on the moon. And with haptic feedback, your hands will actually feel what the robot's hands are touching. Imagine sitting in a control center on Earth, grading spaceports, digging trenches, and leveling terrain, just as if you were standing right there in the moon dust. It's wild. Section 3. Tele-Manufacturing moon bricks. Now, how do we get the building materials? Enter a process known as in situ resource utilization, or ISRU, and it's already happening. Companies like Space recently built a patent-pending autonomous moon factory prototype for under $5,000. Basically, the robots first mine the fine powdery lunar soil, which we call regolith. Then they refine it using a geopolymer process, and finally they turn it into solid structural bricks. We are quite literally building the moon out of the moon. So what exactly are we manufacturing up there? Well, first, we have these really cool Lego-style blocks made through a process called sintering, which essentially uses concentrated solar heat or microwaves to melt and fuse the dust particles together. Because they interlock like Legos, our robots can just self-stack them without needing any wet mortar. Next up, we can actually melt down lava rock to draw out threads, weaving them into incredibly tough basalt fiber sandbags. Finally, we have cast basalt, which is literally just melted and molded volcanic rock, perfect for heavy-duty abrasion-resistant floor tiles and pipes. These are the literal, physical cornerstones of lunar industrialization. Section 4. Engineering. Lee vacuum hangars. Okay, so with these materials, we are engineering what's known as a Lee vacuum. Imagine an unpressurized, massive umbrella-like hangar, sometimes called a ramada. We build this giant space frame, and then we cover the whole thing with meters of that lunar soil we just talked about. It creates this vast, sheltered space that is totally safe from the deadly radiation and wild temperature extremes of the open lunar sky. Now, what's really fascinating is exactly how our tele-operated robots actually build these massive hangars. They use an inflatable construction support balloon, basically a giant slip form.
The robots stack those sintered Lego-style blocks right over this inflated balloon to form a perfect arch. Once the arch is done, they just deflate the balloon, move it forward, and reuse it for the next section. What you get is a massive, self-supporting arch block hangar, and underneath is a perfectly shielded lee vacuum, complete with a smooth, compacted floor.
So why go through all this trouble before humans even arrive? Because the benefits are an absolute game changer. These hangars block deadly cosmic rays and raw UV radiation. They also create a super stable thermal environment. Get this. Temperatures down there only vary by about 3 degrees Celsius year-round, compared to the hundreds of degrees of wild swings out on the surface. It also completely stops the micrometeorite rain. But most importantly, it means when we ship pressurized habitat modules from Earth, we don't have to awkwardly bury them in the dirt. We just park them neatly under the hangar and easily hook them up. Plus, when humans are outside the habitat but still under the hangar, they can wear much lighter, more comfortable pressure suits instead of those bulky, rigid spacesuits.
These lee vacuum spaces also double as the perfect open warehousing area. We can store essential equipment, rovers, and delicate storage tanks right on the surface. They stay fully shielded from the harsh weather of space, but they're still incredibly easy to access without having to constantly cycle through complex, resource-draining airlocks. It's essentially the ultimate lunar garage.
Section 5. Ready for human arrival. All of this strategy leads us to one massive payoff. Almost everything necessary is completely taken care of by robots. So when that very first crew of human explorers finally touches down, they aren't stepping out into a chaotic, deadly construction site. No, they're stepping into a turnkey, ready-to-move-in property. They can hit the ground running and immediately begin doing what only humans can do: advanced scientific exploration and expanding this base into a true, thriving settlement. I want to leave you with a truly fascinating proposal drawn straight from the visionaries who are actively planning this future. What if space agencies held a public lottery? What if the grand prize was logging in from your laptop right here on Earth, getting behind the controls of a Telepresence robot, and actually manufacturing and stacking real bricks on the moon? You could quite literally help build humanity's first lunar settlement from your living room. It sounds like science fiction, but honestly, it's the required next step in our space infrastructure. Definitely something to think about.